Alright, so this is going to be kind of a quick video because if you understand loops and you understand conditionals, this concept shouldn't be all that hard, but it is incredibly useful. And it's what we call nesting. And nesting loops or nesting conditionals is where we put a loop within a loop, or a conditional within a loop, or a loop within a conditional, or a conditional within a conditional. And this is extremely common. You'll probably find more programs that use this than don't once you start programming more complicated stuff. Often there is a different way to accomplish it, but this is usually the most efficient way to accomplish it. So I'm going to show you a few examples of each. Some are really common, some aren't as common, but all of them get used from time to time. So the first example is a conditional within a conditional. And often there's another way to accomplish the task using and statements or stuff like that. But really, this is usually the most efficient and easiest to understand. So in this example, it asks, are you graduating at the end of the year? And it's going to choose to do something if you say yes and something different if you say no. If you say yes, it's going to ask you a follow-up question. The follow-up question is, are you going to college next year? And if you say yes, it's going to ask where you're planning to go. And otherwise, it's going to ask, what are you going to do next year? If you choose no, you're not graduating next year, then these questions don't apply to you. So it's going to ask you a different question. And it's going to say, do you have your classes for next year yet? And again, you're going to say yes or no. And if you say yes, it's just going to say, I hope you're taking advanced programming. If you say no, it says you should sign up for advanced programming. So we're controlling which question to follow up with based on the answer to the first question. And then we're, within that, planning the answer based on what someone did or what someone answered to the second question. Now, it could get awkward if we tried to do this in another way, because we'd have to ask him, are you graduating at the end of this year? Are you going to college next year? Do you have your classes for next year? You'd have to ask all three questions if you didn't have this conditional inside of a conditional. A looping conditional is probably not the most common thing. I was trying to think of a real quick example, and this example in the general scheme of things doesn't make that much sense, but it works to show you, to demonstrate a loop within a conditional. So say that you have a machine, and this machine is either going to make more copies of a document for you or shred copies if you've made too many. So it's going to ask how many copies you have. You say a number, it's going to convert that number to an integer. If that number is less than 50, it's going to say you need 50 copies, and it's going to print a bunch of copies until it gets to 50, and then it's going to stop. If you say more than 50, it's going to say you only need 50 copies, and it's going to start shredding them one at a time until you get down to 50. So this is a loop within a conditional, or really two loops within each side of a conditional. Conditional within a loop, probably the most common thing you're going to see. So this is a simple guessing game. The person asks you to guess the number, the program asks you to guess the number, it converts that to an integer. It then says the secret number happens to be 43. So if you guessed higher than that, it's going to say lower. If you guess lower than that, it's going to say higher. And either way, it's going to ask you to guess again, and you'll note that I converted that to an integer in a single statement. These two statements together I could have put together like I did here, but I just wanted to demonstrate that this does exactly the same thing as these two lines of code. It takes the input, and then once it's got the input, converts it to an integer and saves that to x. And once the person guesses 43, it's going to say you guessed right, because it'll have broken out of the while loop at that point. So this is a pretty common thing to do. Another thing, which maybe not as common but is incredibly useful, is a loop within a loop. And this one actually has a conditional within that inner loop. And this is a program that's going to go through all of the possible combinations of x plus y. So it's going to try 13 plus 33, 13 plus 32, 13 plus 45, 13 plus 64, 13 plus 24, 44 plus 33, 44 plus 32, and so on, until it's tried every combination of numbers between a number in x and a number in y. And then it's going to print out what the largest possible number you could have made by adding a number from an x to a number from y. The way it's going to do that is I'm going to have a little placeholder variable called lgxy, and it's going to loop through x. And as it loops through x, it's also going to loop through y. So it's going to check 13 plus 33, 13 plus 32, 13 plus 45. Once it's done with all of the 13, or once it's done with all of the y's, once it gets through 24, then x is going to go to the next number, 44, and it's going to check 44 against 33, 32, 45, 64, 24, and so on, all the way through. And each time, it's going to see if the two numbers added together are larger than the previous largest numbers added together. So when it gets 46, these two added together, then it's going to check this, which is going to be 45. It's going to say, are these two numbers bigger than 46? No, they're not. How about these two? Well, yes, they are. So I will replace LGXY with that new total. And so in the end, it's going to print out the largest possible combination. So this is a conditional within a loop within a loop. And you'll notice that the nesting can be between x, or it can be in while loops or in for loops. There are other ways to control the flow. One is with the continue, one is with break, and one is with return. Now continue will break you out of a loop, but it will continue the loop running. So in other words, if the condition on the loop is still true, it'll run the loop again. It will just break you out of the current iteration of the loop you're on. So if there's more code within the loop, it's going to skip that code and it's going to go back to the top of the loop and run the next loop again. If you have a loop within a loop, it's only going to break you out of the innermost loop. Break, on the other hand, is going to cause a program to break out of a loop, and it's not going to execute the loop again whether or not the condition is true. And it's going to ignore any more code. In the case of a nested loop, however, it only breaks you out of the innermost loop. And I'm going to show you real-world examples of both of those in a second. The third one is return. And you'll notice both of these only break you out of an inner loop if you have a nested loop. Return will break you out of all of the loops. You could have a loop within a loop within a loop within a loop, and return would break you out of all of them. However, you can only use return inside a function. You can't use it just on straight code that's not part of a function. All right, so let me show you these examples. So right now I have an example here. It's going to print out the numbers from 0 to 9. All right, pretty simple stuff. Now I'm going to throw a conditional in there that says if x equals 4, continue. Okay. Now, I actually need to change something around here, and I'll explain why in a second. Well, here, first let me put this here. So I'm going to run this, and you will see it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So this doesn't actually show us anything yet because of where the continue is, because it's not skipping us out anything. It goes back to the top of the loop. But what if the print x was down here? Watch this. Now you'll see 1, 2, 3, 5, 6, 7, 8, 9, 10. What happened? Well, when we hit the x equals 4 and it said continue, it stopped running the loop. It jumped back up to the top of the loop and started the loop again from up here. If we replace the continue with break, you'll see what happens here. When we replace it with break, when it got to x equals 4, hit break, then it doesn't go back to the top of the loop, it goes to the next line of code after the loop, and there is no more line. Here, let's put a line of code. So you'll see that it jumps out of the loop. On continue. Again, it's going to just skip that 4, and it's going to go until it's done. Now, earlier I told you we had to move this. Why did we have to move this? Well, watch what happens if I put this here. Okay, notice it got to 3, but notice it's still running. It didn't print done. It didn't give me these little arrows that says it's done running. Why is that? Whoops. Control that. Now, when I come out here, the reason is it never got to this line of code after it hit 4. So when it said if x equals 4, continue, jumped back up here. X never got bigger. So it was an endless loop. So you do have to be a little careful with using continue. If I had used break, that wouldn't have been a problem. Right? Because break didn't jump it back up here. Break went to the next line of code. Now, let's do this. Let's say we're going to print a deck of cards here. Okay, so I'm going to have x, y, and I'm going to say x equals, and hopefully you guys know what's in a deck of cards. There's a 2, a 3, a 4, a 5, a 6, a 7, 8, a 9. All right, so a deck of cards has a 2, a 3, a 4, a 5, a 6, 7, 8, 9, 10, an ace, a jack, a queen, a king. Now I got to make these all. So those are all the individual cards in a deck of cards, and that can also be hearts, clubs, spades, or diamonds. The 4 suits. All right, so if I were to, what this is going to do, I'm going to create for items, we'll call them ranks in X, for suits in Y. So the individual cards, 2, 3, 4, 5, 6, those are called the ranks. Hearts, clubs, spades, diamonds are the suits. And I'm going to print out X plus Y. So this is going to print a full deck of cards. All right, so whoopsie, I made a mistake there. I wanted to print. See, I even do that sometimes. Ranks plus suits. And there we go. I have a full deck of cards. I get 2 of hearts, clubs, spades, 3 of hearts, clubs, spades, diamonds, so on. All right. Now, if I say if suits equals H, continue, it's going to, when I run this, it's going to print a deck of cards there. So you'll see that it printed them without any hearts. Clubs, spades, diamonds, because every time it was a heart, it hit the continue. Now, if I say break, you would think that as soon as it gets to the two of hearts, it's going to break, it's going to stop, right? But you would be wrong because of what we talked about before. It only breaks us out of the innermost module. Whoops. What happened there? Oh. So, oh, heart's the first suit. Let's say clubs. Okay, so what happened here is that it ran hearts, the two of hearts, then it got to the two of clubs and it hit break. But that didn't stop us altogether. That only moved us to the next rank. It moved us to the threes. So the break doesn't break us all the way out of this thing. Now, just real quickly, I want to show you what I meant about return. Well, here, let me show. If I try to say return and run this, I'm going to get an error. It's going to say you can't have return outside of function. So if I put this into a function, called print cards, and I call my function, you would think I would get the same result as I did here, but you will find that I do not. So in this case, the function stops running in the instant it sees the return. So return doesn't actually really break you out of a loop as much as ends the function that is currently running. All right, so that's loops, nesting, all that good stuff. That's it.